All right, this is Mr. Gillum, and today we are going to solve quadratics by factoring, okay? But today they're going to get a little bit more challenging than they were yesterday, okay? And so, the first thing I want to remind you of is what mono out is, okay? And mono out, or factor out, is where you look at all the terms and you see what they have in common, you pull that common term out, all right? It's like the opposite of a distributive property, okay? So, if, for example, all the terms you notice have something in common. In this case, I noticed they all have a 3 in common. What I'm going to do is the opposite of the distributive property. I'm going to take that 3 out, and if I take a 3 out of 3s squared, I have an s squared left. Minus 2s plus 1. Now, this is called mono out or factor out. I like to call it mono out because I'm taking a monomial out. 3 times s squared is 3s squared. 3 times negative 2s is negative 6s, and 3 times 1 is 3. So I know I factored it right. Now I'm just going to stop right there for now because I just want to emphasize the mono out part. Okay, and we may be able to factor it more, that's fine, but for now I just want to emphasize the mono out. So let's look at this next one here, and I notice that all of these numbers are even. And I notice that I only have x's in the first two, so I can't pull an x out. But they're even, so I know I can pull a 2 out. 4x squared minus 9x plus 5. It's like the opposite of a distributive property. And just to make sure I did it right, I know 4, 9, and 5 don't have anything in common, so I think that's as much as I can factor out. Now let's just check to see if I did it right here. 2 times 4x squared is 8x squared. 2 times negative 9x is negative 18x, and 2 times 5 is 10. So I know I factored it correctly, and I'm going to call this the mono out rule, or the factor out rule. Okay, and finally I noticed that 15, 5, and 45 all have a 5 in common. So if I take a 5 out, that leaves me with 3x squared plus x plus 9. Okay, and that's just, I'm just emphasizing the mono out for now, and that's what we can do, okay, as far as mono out is concerned, and that is a type of factoring. So if that's the only thing you can do, that is still a type of factoring. That does not mean it's not factorable. You can still factor it. Okay, so let's look at the next part here. Okay, difference of two squares, and we already kind of talked about this yesterday. Okay, in a difference of two squares, you have two terms. The first and the last terms have to be perfect squares, as in 4, 9, 16, 25, 36, and so on. Okay, anything with a perfect square root, x squared or x to any even power will be an even root. Okay, and you're going to start with two parentheses, one with a plus, one with a minus, and the first term is going to be the square root of the first term in your original. Okay, and the second term is going to be the square root of the second term in your original. All right, once again, these are perfect squares. Okay, x squared I know is x times x. 4 I know is 2 times 2, and it is a difference of two squares because of the subtraction sign. So what I'm going to do is I'm going to start with my two parentheses. I'm going to put x, the square root of x squared, which is x, in the front of each of them. I'm going to put the square root of 4 in the back of each of them, and always in your difference of two squares for your special rule, one sign is a subtraction, one sign is an addition. Now, you're probably wondering what happens to the middle term when you FOIL it. Well, let's find out. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. When you add the like terms, all you're left with is x squared minus 4. And this is going to come into play when we talk about conjugates here in the near future. Okay, so this is a really important term, or a really, really big deal, difference of two squares. Okay, so once again, we have another simple problem. We have a perfect square in the front, a perfect square in the back. So let's go ahead and set up our two parentheses, one with a plus, one with a minus. It doesn't matter what order you do them in, okay, because we're still taking the square root of the front and the back number. The square root of the front number is in the front of the parenthesis, and the square root of the back number goes in the back of the parenthesis, okay? And that's it. That's all you do to factor it, okay? And so if you wanted to FOIL it out, I'm sure you would get x squared minus 9, okay? Similarly, this is another example of a difference of two squares, okay? Q times Q would equal Q squared. 10 times 10 is 100, so the square root of Q squared would be Q. The square root of 100 would be 10. We're going to start with our two parentheses, one plus, one minus, The square root of the a term goes first, the square root of the b term goes second, and we factored our expression. Okay, now similar to the trinomials where we had 3 terms, your binomials, like so, okay, this is a binomial because there's 2 terms. You also need, if there's ever a number in front of here, okay, you need to factor it out first. Always check. Rule number 1 for factoring is always look to mono out first. If all terms have something in common, always take that out first. I know that 3 goes into 3 and 27, so kind of like the opposite of a distributive property, I'm going to pull that 3 out, and it's going to leave me with x squared minus 9. If I wanted to distribute it, I would have the same thing, 3x squared minus 27. This is a way more factorable expression for me. So what I'm going to do is I'm just going to look at what's in my parentheses here. I notice, oh, looky there, there's a perfect square, there's a perfect square. So let's factor some more. 3 stays in front. The square root of x squared would be x. And the square root of 9 will be 3. So my finally factored term would be 3 times the quantity x plus 3 times the quantity x minus 3. All right, and so let's look at this last one here. Once again, we have a number in front of our x squared. So let's try to get rid of that number. I'm going to pull it outside and separate it from what we're trying to factor. Now when you pull out a negative number, okay, it comes out of both parts. So be very careful here, okay? Just to make sure we did it right, negative 2 times x squared is negative 2x squared, and negative 2 times 64 is negative 128. So we did factor it correctly, okay? However, do we have a difference of 2 squares? Keep in mind, the word difference makes a difference, okay? If it's not a difference, you cannot factor it any farther. Because this is a plus sign, okay, I know that my final answer after I monoed out is just negative 2 times the quantity x squared plus 64. I can no longer factor that. That's as far as you can go. If it's not a difference of 2 squares, you cannot factor it as a difference of 2 squares. Okay, and that's my factored term. And so that's called the difference of 2 squares. So let's just take a look at some examples here. Factoring, okay. I have 16x squared minus 1. Now before, we didn't have a term in front of this x squared. Life was good. However, today, we do. We have a term in front of there. But luckily, I know that 16 is a perfect square, x squared is a perfect square, and 1's a perfect square. That's not all the criteria has to meet, though. There has to be 2 terms. That's good. And it also has to be subtraction because it's called the difference of 2 squares. Difference means subtraction in math, everybody. Okay, so what we're going to do is this. I'm going to start with my 2 parentheses, one with the plus, one with the minus. I'm going to take the square root of 16x squared. Square root of 16 is 4, square root of x squared is x. I'm going to put that in the front of each of my terms. Now I'm going to look at 1. I know that's a perfect square. Square root of 1 is 1. Now I've factored it, okay? And these are actually going to relate to the next section. And what we're going to learn is conjugates, where the middle sign changes. But that, we're getting ahead of ourselves, okay? For now, I just want to practice, okay? This is the difference of 2 squares rule, okay? So secondly, let's look here. Once again, we have a perfect square, 36, n squared, and a perfect square, 9. We're in luck, okay? We can do this 2 different ways. The first thing we should always look to do is factor out anything they have in common. So let's pull a 3 out here. That leaves me with 12n squared minus 3. Okay, but better yet, I notice they have another 3 in common. So if I pull another 3 out, now I have 3 times 3 times 4n squared minus 1. And so that's 9 times 4n squared minus 1. And what I did was, because these are all held together by multiplication, I just pulled out another number and I just multiplied these together. Okay, and now I notice this is a difference of 2 squares left over. I know this was as well, but look, you're still left with a difference of 2 squares. Isn't that awesome? Okay, so let's move our work up here. I have 9 times now. In the parentheses, I need a plus and a minus. I'm going to take the square root of 4n squared, 2n. I'm going to put him in the front. I'm going to take the square root of 1, which is 1. I'm going to put him in the back. Okay, and now I have a completely factored term. All right, so please, 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 even though it might stick out to you as a perfect or sorry, a difference of two squares, make sure you mono out first. Okay, you take out whatever numbers you can first. All right, and finally, I want to look at this. I want you to be careful on this because this actually doesn't fit the criteria. Okay, this is not a difference of two squares. This would be a sum of two squares, and the rule does not apply unless there is a subtraction sign between the two terms. Okay, so even though 4x squared is a perfect square and 25 is a perfect square, we cannot use our difference of two squares rule on it because it is not subtraction. Okay, now let's look at some perfect square trinomials. Okay, these are just the same as any other trinomial. It happens to be a special pattern, and if you notice it, okay, it's going to make your life easier. Okay, and every time you factor a perfect trinomial square, a perfect square trinomial, you'll get two parentheses that are exactly the same. Okay, let's just factor it like we did before. All right, so we have two numbers that multiply to get 9 and add up to 6. My factors of 9 are 9 times 1 and 3 times 3. I know positive 3 times positive 3 would equal 9. Positive 3 plus positive 3 would equal 6. So in my parentheses, I need x first, and then a plus 3 and a plus 3. Now, if you notice, these two terms are exactly alike. So the way I want you to write them is x plus 3 quantity squared. Okay, quantity squared. And that's how we're going to write them, as our simplified form. Okay, and it's a perfect square trinomial because both of the factors that you get are exactly alike. Okay, so let's look at this next one here. I need two numbers that multiply to get 4 and add up to negative 4. Well, I know 2 times 2 would equal 4. In fact, negative 2 times negative 2 would equal 4. That equals positive 4, and you add them up, they goes to negative 4. This is what I'm going to use right here. Okay, so I'm going to say x in the front minus 2, and as you can see, they are both the same. It's a special thing that happens there. All right, I'm going to write it as x minus 2 quantity squared, and it's a perfect square trinomial. All right, and as you get good at these, what you notice is the front term is a perfect square and the back term is a perfect square. And so without doing all this extra work, okay, I need to kind of think about it, but I know that because it's perfect square, I know that negative 9 and negative 9 multiply to get 81. I can just throw them in there right away. Okay, and as you see them, as you do a lot of these, you'll start seeing them too. Okay, I jumped right to the conclusion here. I know negative 9 times negative 9 is positive 81, and they add up to negative 18. And because this is the perfect square trinomial page, I just kind of skipped ahead. All right, but we want to write this as w minus 9 squared. All right, and so if you want to do them the long way, that's fine. Okay, 64, same idea. It's a perfect square. I noticed that right off the bat. This is a perfect square. Okay, it might be helpful to remind you of all the perfect squares. 1 is a perfect square. 4, 9, 16, 25. And then we have 36, 49, 64, 81, and 100. Those are the first 10, and those are the ones you probably run into. If you ever see those numbers on the back or on the front of these numbers, okay, it's a good chance that you have a perfect square trinomial. So let's just look here. I'm going to go ahead and guess, since we're on the perfect square trinomial page, I'm going to go ahead and guess the square root of 64 is 8. So I'm going to say 8 times 8 equals 64. 8 plus 8 is 16. So I know when I factor this, y plus 8, y plus 8. Okay. My final solution, though, needs to look like this. Y plus 8 quantity squared. Okay. And just like every other factor when we're factoring, always look to pull something out from each term. Okay, because in this next example I have this negative 3 out here. I don't like that negative 3 out there. I'd like to remove it. So I'm going to take it out, but I need to take it out of each term. Now, I need negative 3 times something to equal positive 24x. So I'm going to say minus 8x plus 16. Now, be very careful when you start pulling out negatives. I would always distribute just to make sure. This is negative 3x squared, positive 24x, and negative 48. So I do know that I did it correctly. Okay. Be careful on your signs. Now, because we're on the perfect square trinomial page, I notice it right away. I got 16 here and a perfect square in front. I'm going to say probably -4 times -4 is going to equal 16 and add up to -8. That means -3 times x minus 4 times x minus 4. Okay, the -3 just comes down. It doesn't just disappear. And so finally, the best way to write your answer, -3 times x minus 4 quantity squared. All right. So let's just do this last one more time, okay? If there's a number in front of x squared, always attempt to pull it out first, to mono out. In this case, -2 does go into each part evenly, so I'm going to pull -2 out and say x squared plus 10x plus 25, okay? And distribute just to make sure, -2x squared, -20x, and -50. I did mono out correctly, okay? I know that 25 is a perfect square, x squared is a perfect square, 5 times 5 equals 25, and 5 plus 5 equals 10. So I'm going to say, okay, I'm going to bring down my -2. I'm going to have x plus 5 and x plus 5. So my final solution is going to be -2 times x plus 5 quantity squared. Let's take a look here. All right. Remember, rule of thumb, always look to mono out first and see if you can make your life easier. Okay, I have 9, 12, and 4. Nothing gets factored out. Okay, so I'm done using that step. I do notice that 9y squared is a perfect square and 4 is a perfect square. I have plus plus, so I know I'm going to have in my parentheses a plus. This is a perfect trinomial square. The square root of 9y squared is 3y. Okay, the square root of that guy. The square root of 4 is 2. Okay, I have my factored term. Okay, so if this should stick out to you, you need to have memorized 1, 4, 9, 25, 16, 36, 49, 64, 81, and 100, because they are all the perfect squares. Okay. So let's take a look at this next term. It says 25s squared minus 80s plus 64. I know that nothing that goes in 25 will also go into 24 evenly. So I'm going to go ahead and look at it. It's a perfect trinomial square because I can take the square root of 25, I can take the square root of 64. This time I have a minus plus. So in my parentheses, I'm going to go ahead and say it's going to be a minus right there. The square root of 25s squared is 5s. And the square root of 864 is 8. Therefore, I have my factored term, 5s minus 8, quantity squared. All right, let's look to the next one. 4, 28, and 49 have nothing in common, so I can't mono anything out or factor anything out. This is a perfect square, and this is a perfect square with a minus plus combination. I know in my parentheses here, I better have a minus, and it's a quantity squared. So what I'm going to do is I'm going to take the square root of 4r squared, which is 2r, and take the square root of 49, 7. And this is my factored term here, 2r minus 7 quantity squared. Finally, I have 49x squared plus 42x plus 9. Nothing that 42, 49, and 9 have in common. However, these are perfect squares, 49 and 9. So I'm going to assume this is a perfect trinomial square. It's a plus plus this time, so I'm going to go ahead and make a plus inside my square, or inside my parentheses. I know 7x is the square root of 49x squared, and 3 is the square root of 9. So in my factor term, 7x plus 3 quantity squared.